Hello student, let's see the questions. What is the question here, dear student? This is the NCRT exercise question of the equilibrium chapter. A liquid is equilibrium with its vapor in a sealed container at fixed temperature. The volume of the container is suddenly increased. What is the initial effect of the change of the vapor pressure? On increasing the volume of the container, the vapor pressure will initially decrease because the same amount of vapors is not distributed over the large space. So that is vapor pressure will decrease when you are increasing the volume. Second, how do rate of evaporation and condensation change? So on increasing the volume of the container, rate of evaporation will increase because the surface area increase initially because now more space is available. Now condensation, since the amount of the vapors per unit volume decreased, on increasing the volume, the rate of condensation will initially decrease. Last one. What happens when equilibrium is restored finally, and what will be the final vapor pressure? Finally, equilibrium will be restored when the rate of the forward and backward process become equal. However, the vapor pressure will remain unchanged because it depends upon the temperature and not on the volume of the container. Here you see. What is Kc for the following equilibrium when the equilibrium concentration of each substance, that is SO2 0.6, O2 0.82, SO3 1.90. So Kc they are asking for this one. So Kc will be what, student? The product of concentration of product divided by product of concentration of reactant raised to power their concentration. So on plugging the value you are getting, that is 12.229 mole inverse. Hence equilibrium constant is this one. At certain temperature and total pressure is 10 power 5 Pascal. Iodine vapor contains 40% by the volume of I atoms. I2 plus 2I give it. Calculate the Kp for the equilibrium. So the partial pressure of iodine Pi is equal to pressure of iodine upon 100 P total. So you are getting this one, partial pressure. So here is there. Now use the Kp. So Pi minus Pi2, and plugging the value you will get this answer. Write the expression of equilibrium constant for each of the following reaction. 2NOCl, 2NO plus Cl2, 2CuNO3. This is the these are question. What you need to do, wherever the solids are there, that you need not to take. Solids you need not to take. uh, Aqueous also no, not required. Liquid also not required. Here aqueous you can take, student, otherwise nothing will be left out. But liquid you cannot take because aqueous means concentration only. Here is the solid also you cannot take. So let us see the value how they wrote here. So Kc is equal to, these all are the gases, so all mentions. Solid they left out, here solid left out. So this is what is, acha, gas is there, this is gas. So this is coming. Similarly aqueous is there, no problem with the aqueous. Here is aqueous is there. This is, find out the value of Kc for each of the following equilibrium from the value of Kp. Find out the value of Kc for each of the following equilibrium from the Kp. Kp they have given. Now we need the Kc. So what you can do, Kp is equal to Kc RT power delta n, R value this one, delta n value this one. Kp is equal to this one. Kp is like this, here this is here. For the equilibrium, this is the Kc value. Both the forward and reverse reaction are in the equilibrium, elementary bimolecular. What is the Kc of the reverse reaction? Kc is equal to 1 upon Kc. Kc dash is equal to 1 upon Kc. Explain why solid and pure liquid can be ignored while writing the equilibrium constant expression. Solid and pure liquid can be ignored while writing the equilibrium concentration constant expression because the molar concentration of pure solid or liquid is independent of the amount present. So molar concentration, number of moles upon volume. So as the density of the solid and pure liquid is fixed, the molar mass is also fixed. The molar concentration is